In section 9.2, we're going to talk more about equations, but I wanted to give you some tips of how we're going to do some of those substitutions in the next section. Um, this is called transforming equations between polar and rectangular forms. So we have two things that we're going to do. This is the first one. This is the second one. It seems like there should be three, but it's not. The first strategy is to square both sides of the equation. And that's I kind of apply that second if I can't get through by the first one. Then the next one is to multiply both sides of the equation by r, because sometimes that will put it in a format that you can use. And I typically use this one if I see cosine or sine. Um, I will go ahead and put that in there. All right. Use one of these methods above to transform the equation r equals cosine theta from polar coordinates to rectangular coordinates. Okay, so let's go ahead and try the second method first. Like I said, that's usually the way that I like to go. So r equals cosine theta. So I'm going to multiply both sides by r. So I'm going to have r squared on this side equals r cosine theta. Now remember, with our rectilinear part, or rectangular, x squared plus y squared equals r squared. So we're going to hold on to that piece of it as well. So r cosine theta, we said, was our x component. So we could say r squared is equal to x. Okay, so that's what this equals. That's not a fraction. And then what we're going to do is, because this is equal to r squared and this is equal to r squared, we're going to take this and set it equal to this. So we have x squared plus y squared equals x. Now, at this point in the game, we're just going to leave it like that. Obviously, you're going to move x over to the other side, and you have x squared minus x, and then you have to add something for completing the square. Um, so we're not going to go into that process. We're just getting this initial equation because we're showing the process of it. We will dive into that a little bit later. Okay, so let's go ahead and look at these two examples. I have r is equal to 5. I don't see a cosine or a sine, so I'm going to go with my first one that says I'm going to square both sides. So I'm going to square, so I have r squared equals 5 squared. So r squared equals 25. And then I know that r squared is equal to x squared plus y squared. So I can set that equal to each other. So my equation would be x squared plus y squared equals 25. And then, which is actually a circle with radius of 5 centered on the origin, but we will talk about that soon. B, r equals 4 sine theta. Now remember what we said, the method to use if we have a sine or cosine in there. So I'm going to multiply both sides by r. So I have r squared is equal to 4r sine theta. And if I look at this r sine theta, remember that's equal to y. So now I have r squared is equal to 4y. And of course, we also know that x squared plus y squared is equal to r squared. So I'm going to set this and equal to this. So I have x squared plus y squared equals 4y. And again, I would move that over to the other side, and we would talk about, completing the square. And then from there, we can actually figure out where the center is. All right, transform an equation from rectangular to polar form, from rectangular to polar form. Okay, so remember how we said that y is a substitution for something? That would be r sine theta. And then, of course, we just bring down the 3. So boom, there you go. It's not real hard at all. Here we've got y squared equals 3x. So my y, right, that y is going to be r sine theta, and I have a square on it, so I'm going to put that right up here, is going to be equal to 3 times x, which is r cosine theta. All right, so you're just taking your x value and substituting it in for your polar version, and vice versa here. You're converting that polar um, equivalent of that rectangular coordinate and substituting it with y. Okay, so that's it for 9.1. We will get into 9.2 with graphing. If you want to brush up on completing the square, that would be helpful.